So, four types of symmetry for graphs that they're going to talk about in this section. One is x-axis symmetry, there's the y-axis symmetry, symmetry about the origin, or symmetry about the line y equals x. For the x-axis symmetry, basically what I'm looking at is if I were to pair up points on a graph such that for each pair I've got a segment being the perpendicular bisector, the x-axis being the perpendicular bisector of the segment joining 2 points on the graph, then I've got x-axis symmetry. The other way to think of x-axis symmetry is if I fold, if this were a graph or a piece of paper, I could fold the top half onto the bottom half or vice versa using the x-axis as a fold line. For y-axis symmetry, same kind of deal. I want to be able to look at the y-axis being the perpendicular bisector for pairs of points matched up, and in terms of my folding idea, if I use the y-axis, I could fold quadrants 2 and 4 over onto 1 and 4 over onto 2 and 3, and I get a perfect fold. Origin symmetry. Origin symmetry means that you're looking at symmetry such that if you were to connect pairs of points, a point passing through the origin, you would have the origin being the midpoint of the segment connecting pairs of points on your graph. The other way to think about origin symmetry is if I were to rotate my piece of paper, if this were a piece of paper, if I were to rotate about my center point 180 degrees, I'd see exactly the same picture I started with. And finally, the last type of symmetry is symmetry about the line y equals x. And here's my line y equals x. And you've seen that symmetry before. Basically what we're looking at is you've got on one, if you've got a point xy on one part of the graph, you're also going to have the corresponding point yx. So we'll look at that in more detail when we look at inverses. Note, for x-axis symmetry, clearly you don't have a function if you have something that has x-axis symmetry, because you're going to fail the vertical line test. For a given input, you're going to have two different outputs. For an input here, I get an output here, or I get an output here. Furthermore, how about that output? If I have the point xy in the graph and I have symmetry with respect to the x-axis, clearly I'm going to go down that same distance as I've gone up. So I have the point x negative y on the graph as well, assuming y is a positive number. Y-axis symmetry, you do have a function. Note, you're going to be looking still for each x value. There's one and only one output. Same thing before, as with the x-axis symmetry, we do have some certain patterns we can think about here. Assuming x and y are both positive values and the point xy is on the graph, since the distance from here to here will be the same as from here to here for the symmetry, I then know that coordinates over here are going to be negative x comma y. Again, assuming x is positive. For symmetry about the origin, which is a type of point symmetry, since the origin is a specific point, we have the following. If we have a point xy on the graph, assuming x and y are both positive values in the first quadrant, what point will we also have in the graph? Well, if I'm going to be able to spin this 180 degrees, or if I'm going to be able to let the origin be the midpoint of 2 points on the graph here, then clearly my distance here is going to equal my distance here, so that's going to give me a negative x here. And clearly my distance here is going to equal my distance here, so that's going to give me a negative y on the graph. So if the point xy is on the graph, the point negative x, negative y will also be on a graph that has symmetry about the origin. So for symmetry about the line y equals x, here's part of the graph, here's the other path. Now this graph doesn't happen to be a function. Path fails the vertical line test, but it's a graph. And for symmetry about the origin, if we have the point AB as a point on the graph, we will also have the point BA. In other words, the x and the y coordinates will shift. So for every point AB, we'll also have the point BA on a graph if I have symmetry about the line y equals x. We're going to learn ahead in a section or so that inverse functions have symmetry about the line y equals x. An intuitive way to think why, if BA is on the graph, AB will be on the graph, is to consider that if you're going to go out over here A and then up B to keep your symmetry, this is going to have to be the A, and this is going to have to be the B. Again, here to here to here, that horizontal becomes this vertical becomes this horizontal to keep yourself with symmetry about the line y equals x.